Well folks, it looks like we've got another LCL Communicators NI440DX on the bench in the big box of stuff that has come from the paid customer. So you saw the York 863 if you were watching. So it's not often I see one of these in a box. Made in Japan. I like these, not many other people do. Why have we got one side bobble? Ah, because the other side bobble's on the radio. We've got the destruction book. Now, I'll have a look as to whether our scan is better or worse. And somebody bought a Valor dialer match. Excellent. It's in lovely condition. And I can't put the instructions back in the bag. Well, that's a bit of a nondescript mic. I'm sure it's the right one. It's FM 40 channel transceiver. Yeah, that could go with anything, but it does have the power lead, and it's got the bracket, and it's also got somebody's car radio bracket there. Was it Din D in those days? So, we will try this as it is, without opening it up. Nice to have the original power lead, absolutely immaculate, no sign of corrosion. So we'll plug the test equipment into the extension speaker, we'll plug the external speaker into the PA speaker, that's the one mounted on the wall behind me. It's the one with the clear meter, it's not the one with the yellow meter, so I think this is a bit later production than the one with the yellow meter. Of course, there's always the which one's the best, you know, and I don't think I've detected any difference. So the difficulty on these is because the receiver is harder than most sets to align, most of these, the receiver is out of alignment, and therefore they don't work very well. But in actual fact, the sets do work very well, in my opinion. So we don't know anything about the set. It might look immaculate. So we'll put the power supply on cautiously at 9 volts and at 300 milliamps. That needs some cleaning. This annoys me when it's not central at channel 20. I can't pull that off that quickly. Right, we'll go to 13.8 volts. And we'll start some tests. Right, switch picture in picture on. And we'll start by putting the radio into public address mode. Testing 1 2, testing 1 2 3 4 5 5 4 3 2 1 1 2 3 4 5 1 2 1 2 1 2 1 2. Well, it would work if the volume control was a bit better. We're going to struggle with that, I can see. Right, transmit. So it's not, these sets don't normally do 4 watts. They're usually a bit above 3. This one at the moment is doing 2.5 watts. And the Roger bleeps on because I heard it come through the test set. So I'll just switch that off. Let's look at DV. Oh, we'll look at frequency next. So we should be getting 27.79125, and it's way too low. It's illegally low. 27.79042. So that does need to come up. Let's look at deviation. Wow, low. 1.5. So with the signal generator, if we tune the signal generator to the receive frequency the radio is on, so instead of putting 27.79125, we'll put 27.79. I'll just show you this, so I'm not making it up. 27.79042, and then it's a fair test, and we're not going to test the radio on one frequency when we know that there's radio set to another. So there we go, that's now fair. We should switch the cyanide meter on. We'll put the camera on that. And if we can get some, something to come through. RF gain not in the right position. In fact, the receive sounds very good on this. It's doing 0.74 microvolts for 12 dB cyanide. Just turn the volume down. So there's the 1, there's 6, 7, 8, and it's the second line across 0.74. So this radio is off frequency and it's got a very noisy volume control. It's doing 2.5 watts and the deviation is low. Typical of a set as it comes out of the box. Nothing changes, you know, folks. Nothing changes. They're just as dreary as they come out of the box today. Put the soldering iron on ready. So I think we'll start by trying to put it back on frequency. So it's going to be the reference crystal there, not to be confused with the VCO there, which we don't intend to touch. Switch it back on, press transmit. Tell you what, it's gone, hasn't it? Wow. That was so far out, I was beginning to think it was out of, the crystal was out of spec. So we've done that. Right, I'll pause the video and I'll get my service notes. Right, I'll switch it back on. I've cleaned the volume control. It's one of those semi-sealed types, not easy to work on. So let's see whether we can bring up the transmit. I certainly want it above 3 watts. So transmit. 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 Change tools. This is 3 watts. And that's where it's going to be. Right, I think it's time to set the meter. I'll change his glasses. If I remember rightly, it's this one at the back. This is fun. Prop the radio up. What's it saying? Oh, it's saying 4.5 to 5. Well, we have it on 4, even though we know that it's doing 3. It's just doing above 3. Let's call it 3.1. So on low power, it's adjustable on these radios, and the low power switch is inconveniently at the back. Hope you've been enjoying our low power tests, which were suggested by a viewer and was a really good idea. So at the moment it's doing 300 milliwatts. So we want it up just to there, and low power is that preset. There we go, 400 milliwatts. So the next thing we're going to need to adjust is deviation, and we know that was quite low. And it's the one on its side just there. I don't like vertical presets. Wow, that's too high now. Try and leave the tool in. Wow, that's spot on. They really have good audio, these on transmits. I just need to retrim the transmit frequency now that everything's warmed up. we go. Right, so we'll fill a bit more of this in. So we brought that up to 3.1. And we brought that up to 2.2 to 2.5 max. So it's your average is around the 2.2. So now it's the receiver, and the receiver is the hard bit because it's unconventional. Let's switch the oscilloscope on, and we'll go over to the oscilloscope, which is there somewhere. Wow, found it. Right, 100 microvolt signal, just so we've got a decent sized trace. I'd rather fiddle with the volume control than fiddle with the adjustments on the oscilloscope. That's why we have two oscilloscopes. If I'll do this adjustment, and because people have discussed this with me. Detector, I think, is that one. It's not. That's IF injection. It's up there. That's detector. Yeah, and that was out. So I'm glad I've done that. So I'm just widening this shot. I'll just turn the volume down so it doesn't annoy people. I'll just widen this shot. And then move the camera to the right. We've actually got two identical oscilloscopes. The CRT oscilloscopes, I only bought them a couple of years back. They're dead cheap. I think they're about £100 each. They're dead cheap as oscilloscopes go. ST16Cs, a 10 meg scope. They could just as easily be 1 meg scope, the single trace, and I've got the right hand one is on transmitted audio, and the other one is on the detector. So the one on transmitted audio takes the output of the deviation meter. So the Marconi test set I'm using has an oscilloscope output, so you can look at AM modulation or FM deviation. You can look at the audio. We have that on the right hand oscilloscope when I need to. It's not often I need to look at that. It's not on right now, as you can see. The left hand one is just across the extension speaker for maximum recovered audio. So we're only looking at audio on either of those oscilloscopes. But it's cheaper to have two of those. If you think how much time would be involved in resetting all the knobs every time you have to go between looking at the modulation or the deviation and looking at the detector on the receive. So we just have two oscilloscopes. It's cheaper. And they could just as easily be these £15 kits from China. You know, it's all we're looking at. I'll just pop that off and we'll go over to the synapse meter. Just like that. So it's actually working well. So we want about 4 dB on there, so we're not saturating the receiver. And we start with the coil here. So as we get a better signal, the needle will move to the left, and then I will increase the signal on the signal generator to balance it back to 4 dB. So that's worse, and no improvement I could see. Next one. Worse, no improvement. And we'll move on to the other ones. No improvement. Put the biggest signal on. I think we're moving on to the IF now. Let's check it with a small signal. Biggest signal on that one. drop it down a bit. Right, just drop this right back down again and we'll just start again. Because now the IF's right, I might be able to get a fraction more out of it. And then we'll do the IF injection, which takes a signal from the synthesizer and gives the intermediate frequency, IF, its reference frequency. And that was spot on. Okay, so let's read off what we've now got. So for 12 dB, we've now got 0.63. So we have improved it. It was 0.74, it's now 0.63. Let's see what we can hear it down to. Well, that's 0.3. I'm going to change tones. I'm going to find the right switch. Hear it down to 0.15 of a microvolt. So the sensitivity is there. Good. So that's another thing done. So we'll put the signal generator now on a 100 microvolt signal, and we'll put that on the attenuator. So we want to calibrate S9, and it's actually nearly bang on. Now then, I think it's that one. Yes, it is. Now we have S9 showing. So it's just under the wiring there. And that just leaves us with squelch. So, set the squelch to full. And I want the squelch to open when it reaches 100 microvolts. So 1, 3, 10, 30, 100. It hasn't opened. 300, 3 millivolts. It's opening at beyond plus 30. At least it does open. Some sets it never opens, which is ridiculous. The squelch preset is just there. So I've put the signal generator back to 100 microvolts. And we'll twiddle this until the squelch opens, hopefully. Yeah, it does, just there. So now we'll do that test again. 1, 3, 10, 30, 100, it's come in. Okay. Now we'll do the opposite. I'll put the signal generators to standby. I've parked it at 0.3 of a microvolt. And on the radio, we'll turn the squelch down. That one's cleaning as well. And we'll set that to threshold. Switch the signal generator back on. And let's see when the squelch comes in. The squelch is opening at reliably about 0.75 of a microvolt. And then dropping off about 0.5 of a microvolt. So it's got a good hysteresis, so it should track well. So there we have it. I'm going to finish it's evening now. I'm going to finish. And I'll come back to... We'll do this tomorrow morning. And we'll just put this on the aerial and just finalise it. So that's worked out fine. So the next day, we've put it on the Antron 99 roof aerial. We'll see if there's any good or bad buddies out there. One and a Roger. Well, there shouldn't be anybody on UK channels from abroad. I think we've got a bit of a lift on. And of course, they'll all be off frequency. "19 a Roger." Okay, well, as usual, we're not going to pick much up. 28, there's some quarry workers on there, or is it some farmers? No, I think it's quarry workers on 28 anyway. Or is it lorry drivers? Somebody anyway, we do know that it regularly gets used, along with Channel 9's a local farm. So there we are. We have the LCL Communicators NI440DX in beautiful condition and working nicely. So we'll do an on-the-air test later on today and see how that works for us. Thanks for watching.